In Lesson 18, we're going to compute the actual lengths from a scale drawing. Example 1, basketball at recess, tells how Vincent has proposed an idea to the student government to install a basketball hoop. He presents his plan to install the half-court design that's shown below. And after checking with the school administration, he's told it will be approved if it will fit on the empty lot that measures 25 feet by 75 feet on the school property. We need to determine whether the lot will be big enough for the court that he planned. They give us information that the scale drawing represents 1 inch to 15 feet of actual length. And we can see the measurement of 2 inches long and 1 2/3 inches high. We're going to take that information and create a table. And our table should be scaled lengths to actual lengths. If the scaled length let's go back. If from our scale, let's put that in first. If the scale is 1 inch, the actual measurement will be 15 feet. We'll ignore the units for just a moment. When the scaled measurement is 2 inches, we would expect it then to be 30 feet, since we can clearly see that the constant of proportionality would be 15 to 1. And we'll take it one step further. And if the scaled measurement is 1 2/3 inches, then the actual measurement would be 25 feet. So when we go back and look at the measurements that Vincent has proposed, we can see that it would need to be 25 feet wide and 30 feet in length. Checking back, the lot is 25 feet by 75 feet, which means that it would fit on the 25 feet by its width, and there would be extra for the length. Example 2 shows a diagram that represents a garden. The scale is 1 centimeter for every 20 meters of actual length. We're going to find the actual length and width of the garden based on the drawing, knowing that each square in the drawing measures 1 centimeter by 1 centimeter. Just to clarify the scale for ourselves, we'll set up a little table as well for scaled to actual. And then enter in the scale, which is 1 centimeter for every 20 meters. Under those circumstances, we could extend our table, and 2 centimeters then would mean 40 meters, 4 centimeters would be 80 meters, and 8 centimeters would be 160 meters. Now we can go back to the garden and see how it measures. The centimeter squares on the outside of the garden are not included as part of the garden, but they do help us to measure. So the length of the garden is 8 centimeters in the drawing, and the width of the garden is 4 centimeters in the drawing. So if we come back to our chart, we can see that the garden itself will be 80 meters by 160 meters. In example 3, the graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture shown so that 2,500 inches on the scale picture, or 1/4 inch on the scale picture, will correspond to 1 inch on the actual advertisement. We want to know what the length and the width of the tablet, what will be the length and width of the tablet on the advertisement. So we start again with our scale to actual. And if it is a 1/4 of an inch on the scale picture, would be 1 inch in the actual advertisement. These are the same units, so they are representing the same thing. It follows then that if it is 1 inch scaled, it will be 4 inches actual. But on a tablet, we need measurements that are also much smaller. So we're going to take a look at measurements that after we measured the tablet in the picture, we would find we should have 1.5 inches for its length. And if we multiply that times 4, we would get 6 inches on the actual tablet. And then finally, if we measure the width, we should find 1 1/8 inches, and that will translate to 4 1/2 on the actual tablet. In our final activity for Lesson 18, we find a situation where students from the high school are going to perform one of the acts from their upcoming musical at the atrium in the mall. They want to bring some of the set with them so that the audience can have a better feel for the production. But the backdrop that they want to bring has panels that measure 10 feet by 10 feet. They're not sure if they'll be able to fit those panels through the entrance to the mall, since the panels need to be transported flat or horizontal. So they get a copy of the mall floor plan, and they use this diagram to decide if the panels will fit through the entrance. Our scale is 1/8 inch to 4 1/2 feet in actual length. And they have given us one measurement, and that is 3/8 inches in the mall entrance. So if we take our scale and we set it up 1/8 of an inch to 4 1/2 feet, when we calculate that, we find the scale factor to be 36. So when we go back to the measurement of 3/8 inches, we can multiply our 3/8 times 36, which would give us 13 1/2 feet. Checking back, the panels are 10 feet by 10 feet, so 13 1/2 feet would be enough for them to bring the set pieces. Please continue on with the problem set.